Hi, I'm R.D. Peters, and I'm back to talk to you about the builders of Stonehenge and how the ancients built this fabulous monument. And before I get too far into this video, I'll show you a segment from my previous video on how they moved the larger stones by using a device that worked much like a crutch and a swing to keep the center of gravity very low and move a 40-ton stone block with the minimum of force needed, and how they were able to do that. So I'll go back to that video, and then when I come back we'll go from there and I'll show you the next step. Now they refer to these technically as burr stones and sourcing stones and so forth. But to keep things easy, I'm going to refer to them as uprights and cross bearers. That way, plain English, we know what we're talking about. And some of the parts I used in this model are not painted due to the weather here being colder and damper than it was when I first began, and paint did not want to dry correctly. But we'll get through the video anyway, despite our weather problems, and I think you'll find this next segment very interesting. So I'll be back shortly after you review the next segment and see how they moved the large stones from their original quarry to Salisbury Mound, where the Stonehenge stands today. Thank you. I set it up again, loaded it, in the exact spot it was on that first pull. And we'll give it another reading here. Okay. That pull there shows it's up to 14 inches. So in two pulls, we moved 40 tons, 28 feet. Now for the ancients to reset this, they would have did this one leg at a time while tension was kept on the ropes. With this being designed the way it is at the top, that allows those moves to be made very easily. And of course this may have worked better had I not left these weights attached to it, but I don't have enough arms and I have to use the weights to help me keep this upright. And with the skids on the bottom of this, that means there'd be very little wear and tear on that carriage. So even if they wore out the skids on the bottom, it would have been very easy to just bore out the existing pins, put two more rudders on it, drive the pins up through there again, it's ready to go. So that's my opinion on how ancient man moved heavy stones across the terrain. And also, this is an uneven aggregate I have here. by moving the legs in or out, a person is able to adjust for the different curvatures of the terrain. And of course, if you got too dramatic, they could always place a flat stone under one or the other to give it more of a level pull, so that the stone would move forward in a straight line. And hopefully this model puts insight out there on how it was actually done without the assistance from extraterrestrials. Okay, we're back here now at the plain or the mound at Salisbury, and this is my opinion of how a job site like that may have appeared in the beginning. For example, these here are going to be the top cross stones, and it's my estimation that they would take many of these to the job site first because they're smaller, and that's how they basically perfected their technique to work their way up to the heavier uprights. And in doing so, they would have used a lot of different wooden blocks and levers. In this model, 1 pound equals 1 ton. This is a steel block, weighs 20 pounds. I'm sorry, 1 pound. My mistake. 1 pound equals 2 tons. This is 20 pounds. It equals a 40-ton stone. And a ½ inch equals 1 foot. This here it's 20 inches long, ½ inch diameter. It's the equivalent of about the size of a utility pole. And then I believe they would have many other blocks and posts and items to use in the building process. That way, whatever the need was, they could grab it and use it. These would be, a 1/4 inch by 4 inch. They're equivalent to about the size of a railroad tie. Pretty close. And then this here would be, pretty good sized stump of wood. Of course, I use things off the shelf. And here's some blocks they're going to use to upright this heavy stone. And there was some trial and error in this. And what I'm going to do now is show the this upright being stood up and how they would have done that. And with a log about the size of a utility pole, they already have it on their carriage. And I'm going to use the frame of my model here just to keep things simple. And I need this area in order to hook up this this rope and put a scale on it and show how we've decreased the weight. Now they may have used 2 of these poles, 2 teams of men, but it's very possible they actually just used 1. Now this is the weigh scale, and to lift that upright, to get it to move. I don't know if you can see it because it's so dark down here. It's not even, it's just barely moving the needle there. We might be showing 2 pounds of force needed to start this moving upward. Okay, now I'm going to reposition this block toward the center of my model here so I can show you in more detail how this was accomplished and how they got this stone standing upright. Here we are with the upright stone on its carriage after being brought to its last resting place, and the device attached to it during movement has been removed, and now the builders would resort to putting it upright. And in creating blocks for this, I originally was going to use the round blocks to simulate trees that they would have had, and they may have used just round logs and notch them, because what we're going to do is stack these up under here. But after thinking about it, I thought they may have put some flat sides on blocks to keep them more securely in place. And in making this, I realized that making a block, they're notched in order that they can be locked together. It was necessary to put a radius on this outside. Otherwise, at least a little bit of pressure just breaks off this leg and renders it useless. And I also would like to say that I'm using an aggregate here that would be more difficult to work with than what the builders of Stonehenge would have. In these next segments, I'm going to put some actions into place, and then I'll break away and come back and show the different stages that was used to upright this leg, this upright. And what we're going to do is build an articulated base in stages, and each stage you'll see a break in the action as I go back and forth to manipulate the model. And first thing I will do is show how the carriage is removed. First, they would have placed a set of blocks in the front of the upright, and that would be so they could put a lever in there and force this part up. At the same time, there'll be some wood placed here to begin this on its upward movement. Okay, this next stage shows that they have raised it to some degree, placed some temporary blocks there, and made a better fulcrum here in order to raise it higher on the next move. But as you can see, it's starting to go upward. Okay, on the next move here, it was pried up and a block was placed here to hold it, at which time the entire fulcrum platform was moved forward and another piece added to the top. So next time this is pried upward, the carriage will be moved out and away from the upright stone to leave a void here, and the weight of the upright stone will come down on this stack that's been used for the fulcrum. Once this is moved, then they could begin to build an articulated system of interlocking blocks to upright this piece of stone. Now they have the stone in place with the carriage removed so they can begin the next stage of uprighting this leg. We'll go to that. Now, as you can see, interlocking blocks have been placed, and they're very universal in using both for the fulcrum and for the riser to bring this upright to its standing position. And down here you can see the importance of a radius. That allows this piece of wood here to be adjustable and to create this articulated riser that's going to bring this upright to an angle that is going to allow it to be stood up in a vertical position with very little force eventually. And I'll just go back and forth from the fulcrum to the lever until it becomes upright enough in order to again attach the device with ropes and legs that was used to move it from its quarry to where it will be light enough or more upright so that with a minimal amount of force it can be stood at a 90-degree angle. Okay, here's my opinion of what might have been done. As in my case, where I started running short on blocks, to save myself some work, I went back to using a very strong structure. It's already been used before. It's a carriage. Placed blocks on top of it to use for the fulcrum. I would assume that the ancient peoples would have had the same common sense. And you notice here how I have been moving these blocks this direction to give it a radius, how these radiuses in these blocks has helped make a difference. Up here, it gives it a little bit of slippage. It allows it to make this radius. On these here, I've placed a peg into the block. Keep this in place as we go up with it. And once I have this to about a 60 or 65 degree angle, then the leg can be uprighted with the use of ropes, because at that point the amount of force it takes to move it the rest of the way is much easier. And there's about one more set of blocks we got to put in here to get to that point. And Of course, this is my opinion on how it was done. No one's going to have the exact correct model. But we can be assured that they used a very similar method. And when going through the process with the model, you encounter the same problems that the ancients would have. And like I said before, this aggregate's very slick, difficult to work on. With actual earth and groundwork, it could have been easier than this. They may have pegged these down into the ground. We have no idea of knowing for sure. There's a lot of information that's missing in action. But for now, this is my opinion on how it was done. I'm going to be back with another segment. Here we are at one more stage as this articulated riser keeps pushing it over and up. Okay, here we are, and I believe this would have been the last position they would put this in, because once you get to this point right here, this riser would want to fall in on itself with trying to get another layer onto that. As it is, it goes real well with just this number of blocks placed in there, and that gets us to a point. I don't know if you can tell. Well, this you can read pretty good. That's 70-degree angle. And I get this position right. It looks like we're at 65 degrees right there. And that is as far as they would go with working with this type of idea. I mean, they would use their lever and fulcrum, prying different places and positions till they got the stone to that point. It's not very difficult. It takes very little force. And like I said, they only had to solve this problem one time. And it worked for everything. And that's the same with me also. I also have tested the strength of this. And I can shake this whole table very vigorously. I mean, that's, by shaking the table, we're talking the equivalent of a major earthquake. And it stays in place. Now I'm going to place a rope on it, or the moving device, and then we're going to attach the crutch and ropes device to it. And we're going to see how much effort it takes to upright this the rest of the way. And I've placed an upright stone here because I believe they would have done that also to help stabilize it, to get it standing. And it would take approximately 4 crews, 2 to pull it over, and the other 2 with ropes to help hold back on it to keep it from going on over. So we'll get that set up and test the amount of stress needed to upright it. Before I move to my next step, I also want to give this position of it, show how it looked from the end here, going up. Give a little more perspective on the what the model looks like. Okay, we're back to the device that was used to bring the stone to Stonehenge, to the Salisbury Mound. And I had to put a C-clamp on there because the smooth surface wouldn't allow me to tie my ropes to it without them sliding off. So they're tied right there at that point, the top of the stone. I have these draw ropes here. Comes down to the stone, to the weight gauge to show how much force is to be used. This first line here is 5 pounds where my thumb is located. And we have that stone at a 65-degree angle. And now pulling on that will indicate how much force is needed to upright it. It's already moving at 3 pounds. And from that point, that's all it takes, is about 3 to 2 pounds to upright the stone. Then I have simulated team at the other end with those balls of sand that keep it from falling over too fast. And of course my aggregate at the base of the stone does not want to work with me right now. It's to hold that in place, but I think it's going to stay this time. So that's how it was done. And like I said, you know, the scale indicated it only took 3 pounds of force to move that from this point on an articulated riser, which brings it up into increments and makes the job pretty easy. Now my next part of this project will be showing how they got the uprights on the top of the lays. And it's going to be very much the same kind of process, but I'll go through it step by step and show you how it was done. That concludes part 2, and I've displayed how ancient peoples were able to stand a 40-ton block upright without the assistance from extraterrestrials or aliens or Merlin magician or any other such fantasy. I'm a person who in my younger years I built riverboats and I moved objects on land that weighed up to 20,000 tons. And I think I've reasonably displayed how it can be done. And I've estimated there must have been a civilization of about 10 to 20,000 people in and around Stonehenge, and that they had some pretty good chieftains or captains that were able to muster enough people and motivate them to build such a monument. It's a pretty big undertaking for those times. And I've enjoyed doing this, and I do apologize for misspeaking and calling uprights or crossbearers uprights. And I think, though, that you were able to see through the display how it was done. And I will create part 3, and that will show how the cross pieces were placed on top of the upright lays. And Hopefully that this has given you some insight into what mankind with a little bit of ambition and ingenuity can do with the bare essentials. And this may be something that our astronauts will have to resort to as they begin to explore other planets such as Mars and that in the future, because they're not going to have the luxury of taking heavy equipment to those planets with them. And to make progress, they will have to use what's there in nature and use their own ingenuity and techniques to master nature and survive its natural forces. But this has been a good project. I've really enjoyed it, and I hope you have also. Thank you.